Hi, welcome to Ms. Carranza's geometry class. We're starting with the very first section in our study, which is in geometry. Just as a brief introduction, geometry is the study of shapes like circles and triangles and squares. And we'll be looking really closely at how these shapes are made. And in order to do that, we should start at the very beginning with words that we can't really define. They can only be described. These words that can only be described are called undefined terms. And these undefined terms can only really be explained by examples. And we're going to use them to define all the other terms that we're going to use in our study of geometry. These terms are points, lines, and planes. The first term, point, has a description that really doesn't have a size, and we use it to represent an object or location. We name it using a capital letter, like the letter A, and we represent it with a dot. Now, the size of the dot really doesn't matter, so this dot's kind of big. We could use a really tiny dot, but again, the size doesn't matter. It's just a representation, because an actual point doesn't really have a size. Our next undefined term is line. It has a length, but no width and no depth. And we use it to represent the set of points that extend forever in one dimension. Now, we need to take a moment to decide what dimension is. Dimension is a allowed direction of movement, like left and right. If you're restricted to just left and right, you're restricted in one dimension, even though you have two directions you can move. I hope that's not confusing. Anyway, lines can be named by a lowercase cursive letter or any 2 points that are on the line. Like in this picture, that lowercase m could be the name of the line, so we could have line M, or those 2 points AB can be used to name the line AB. I'll show you how to write the line symbolically in a few minutes. Which leads us to one of the main points in geometry, the very first thing that we need to be able to say, and that is through any 2 points, there's exactly one line. Our last undefined term is plane. A plane has a length and a width, but no depth. We use it to represent a surface that extends forever in I wrote all directions. I meant two. It extends forever in 2 dimensions, is what I meant to write. Sorry. A plane is named by a capital cursive letter, or any 3 points that aren't on the same line. Like in this picture. I could use that cursive R to name the plane R, or I could use those 3 points that aren't on the same line, the same straight line, ABC, and name the plane ABC. This is our next little statement in geometry. Through any 3 points not on the same line, there is exactly one plane. This idea of on the same line, not on the same line business that helped us determine if we were talking about a plane or not leads us to some kind of fancy words in geometry that we're going to be using a lot. So let's go ahead and take a moment to discuss what these words are. The first word that we have is collinear. Collinear means things that are on the same line. Let's look at these points. A, B, and C look like they're sitting on the same line. We can draw a line through them and yep. Okay, so B didn't end up right on the line, but let's pretend it did because it was really close. We say that if they're on the same line, they're collinear. So A, B, and C are collinear. A and D are collinear too. I can draw a line through those. Suppose I could draw a line through B and D also. That would be collinear. And even though there's not a line pictured, or I didn't draw one, we can't forget about C and D. They're collinear also, because if I wanted to, I could, but I didn't. But if we look at A, B, C, and D, those aren't on the same line. So let's come up with another word. we could say that they're non-collinear. That prefix non means not. So this gives us that the set of all points that all lie on the same line is collinear, and the set of all points that do not lie on the same line are non-collinear. We can extend this concept into planes and talk about things that are coplanar, all on the same plane. Like in this figure, A, B, and C are coplanar because they're all on the same plane. And the line that connects A and B, line AB, they're also coplanar too. There's the symbol for line AB. That little double arrow thing above the letters A and B, that's how we'd write it. But if we looked at A, B, C, and then this point D that is floating off all by itself, those are not coplanar because D is sitting off by itself. And if we looked at the line that extends between D and B, well, it's really hard to draw on a flat sheet of paper. You kind of have to use your imagination that this line is kind of going behind the plane that I drew, and as it connects to B, it kind of pushes through the plane P and kind of spits out above it. Anyway, that line DB isn't coplanar with our original line, AB, because, well, AB is on the plane that I drew, and line DB is not. So all of these objects that aren't on the same plane are called non-coplanar, because they don't lie on the same plane. So we have the set of points or lines that do lie on the same plane. I know I wrote line. Sorry, I meant plane. Those are coplanar. And the set of points or lines that do not lie on the same plane, non-coplanar. So we've got points, lines, and planes already described. Well, let's talk about space for a moment. Space is a set of all points, boundless and three-dimensional, so it has length, width, and depth. We don't have a really good way to write the name of a space, at least not that I found. Go ahead and check out Google or Wikipedia, see if maybe you can find a way that they name space in geometry, and let me know in the comments below. Anyway, here's a picture we have of something that could represent a space. Notice we've got a lot of different planes going on here. We could name each of the planes by those little points that we see. We only really need 3. We could use all 4 if we wanted, like the top of this box-looking thing. Plane ABC, well, we could call it plane ABCD if we really wanted to. Or the right-hand side of that box. I put a little cursive A in there. So we could call that plane A if we wanted. And of course we've got some lines we could look at, like line BC on the top of the box, or line FD that kind of goes along the back side of the box. That dashed line kind of means that it's kind of behind the surface that's in front. Again, it's kind of hard to point out and draw three-dimensional things on a flat sheet of paper. Sorry, I don't have really cool animation graphics to show you. Anyway, so we have this space box looking thing. It allows us to talk about and define a couple of their terms. The first term that we can define with it is parallel lines. These are lines that don't intersect, but when we're talking about space and planes, we can be a little more specific with our definition, and we're going to redefine parallel lines to be coplanar lines. These are lines that are on the same plane that do not intersect. I've highlighted a pair of those in yellow. Line BD is parallel to line AC. Okay, so we've got a pair of lines here that lie on the same plane and they don't intersect. But could we have some lines that aren't on the same plane that don't intersect? Well, sure. Let's take a look at that line BD again across the top of this box-looking thing and say line CG. I've highlighted it in purple. That's on kind of the front right edge of the box. Those are definitely not going to touch, but they're not going to touch because they're not on the same plane. If we pull BD forward to where AC was, then AC, or what was BD, now AC, would be on the same plane as line CG, and then they would intersect. But since our line BD is on that back part of the top plane and the line CG is on the right side of this front plane, they're totally not on the same plane. And so we call those skew lines. Skew lines are non-coplanar lines that do not intersect. When we have two lines intersecting, such as line AC and line CG, they intersect at a point. In this case, point C. When two planes intersect, they intersect at a line. Let's take a look at the top of the box. I colored it in yellow for you. Plane ABCD. Well, that top of the box is going to intersect with the side of the box, this plane that I've colored blue. Plane CDGH. They intersect at the line that contains the points CD. So two planes are going to intersect at a line. Well, when a line and a plane intersect, they intersect at a point. I don't really have a good line here, so let me go ahead and draw another one. So here's a little line, and it intersects the top of the box, and I have to use dotted lines to show that it kind of goes into the box, and the top part of the line kind of shoots out of the box like a laser beam or something. And I'm going to call that intersect point T, just because I don't already have a letter T on my, so anyway, there it is. So two lines intersect at a point, two planes intersect at a line, and a line and a plane intersect at a point. And of course, I could get really fancy with my picture and draw all sorts of planes intersecting in the middle and figure out where they intersect at, and then my picture gets all colorful and rainbow, and if I keep going, it would probably get really messy and confusing. So anyway, let's talk about some more definitions and vocabulary words in geometry. The next word we're going to talk about is segment, in particular a line segment. It's a part of a line that has two endpoints. What's an endpoint? Well, it's a point that's the end of a segment, kind of like what you're going to see in a moment. Anyway, line segments are named by those endpoints, and they can be in any order. So this line segment could be named AQ or QA. Now, line segment is different from this next word, array. Array is also a part of a line, but it only has one endpoint, and it continues forever in the direction away from that endpoint. Let's go ahead and update my definition for endpoint real quick. Points at the end of a line segment, or array. Array is named by its endpoint and any other point that's on the ray, and in this case, order does matter. So when I draw this ray, I have to go from H to I. So this ray's name is ray HI. And that's the basics of points, lines, planes, and some of the vocabulary words that you can start to build using the concepts of points, lines, and planes, and using those words to define everything else. I'd like you to really pay careful and close attention to how we wrote the symbols for line. The symbols for line are written with the two letters that are on the line, and then a double arrowed line above them. Line segments also named with 2 points on the line segment, but in this case the little bar that's above those letters doesn't have any arrows. And for array, it only has one arrow. That arrow is always on the right. That signifies the direction in which the ray is pointing toward whatever point you've named there on the right hand side. Thanks for watching. I hope this helped out, and again, leave comments down below if you've got any additional questions, or if you found, like for space, a way to name it the way we name points, lines, planes, segments, and rays.